Welcome back, generals, to another Let's Fix the Generals 0 hour to make the best game ever. Okay, so we are still developing unassemblize tool, of course, and we are also closing in shortly to 300 videos in the series, which is not all that much if I think about it. I mean, if I would have started making videos from the first day I started the whole fixing efforts, so after Gen tool, like 3 years ago, right? So then we probably would have had 1,500 videos or more, 2,000 videos. More, I don't know, 5,000 videos. I mean, now it's like, I don't know, 3 months, 4 months, 300 videos. Yeah. Goes fast. Okay, so so in the last video, we have made some submits and we also started some optimizations here. And there was one more optimization. Let's see. Runner. No, ImGUI app. Here, this one. So essentially we have a span, and here we do pushback is matched. Sorry. So I think we can simply do the same approach. So call this prior selected matched function indices set. Yeah. And we populate that with begin and with end. And use this lookup set is much faster than linear search over elements. Okay, and then here we check dot count. How do we do it here? So we say if count is not 0, then continue. Otherwise we do this here. Okay, performance, yeah. Okay, and then the set we hold on. Where is index? Yeah. Yeah, this should work. Let's create a breakpoint in here. See if it works. So this set will essentially be 0 if this is 0. Yeah. So there shouldn't be any allocation if the range is 0. Yeah. Okay, so we select single bundle, and then we select something here, select all, and now we select something here, and now we have one selected function here, and it's not matched. Now we select all, and let's put a breakpoint in here. There we go, matched info. So this should now always hit continue, pretty much, right? Let's see. Yeah, continue, continue. So we should never reach here, and we never do. Yeah, okay. Okay. I expect this also very fast now, this code here. Yeah. Linear search over users look is much faster than linear search. Okay, cool. I think the performance optimization effort is essentially done. Let's see. So we added the set. Fast route, the filter contains all elements. Um, yeah. Yeah, I think it's fine. Okay, cool. Then we save this on the by the way, do we have other cases of has value? That's in an assert. Assert not has value. The selected bundles. Okay, well, this is also quite expensive here. It is debug only, but still, oof. Oh. Yeah, it is a little bit expensive. Shit. Well, we could also create a hash set here, just for release, for not release, right? Yeah, so what we could do is here, we say if and def, what was our, was it release? Yeah. So if and def release and if, and we say here std unordered set set index t and got this here, then we reserve it here, dot reserve. Well, before we test this, before we do this, let's take a look. So basically, there should be a bit of a lag if we select like a lot of bundles. This is the way. Well, I mean, we don't have so many bundles yet, but let's see. So let's say we select all these guys here. Oh, it's hard to say if there's a lag. It feels a little bit laggy, but it's hard to say. It's not much. It's not much, but I assume that this has some cost here. If we put a breakpoint here, it will run. And so eventually, yeah, it has to, it does go into n squared, half of n squared complexity. So I mean, right now we only have 345 functions at max, so it's not like super long right now, but let's say there were 10,000 functions in here, then this assert would also be very costly, right? So I guess we can test this by, if we remove this condition here, so that it also builds it also builds a bundle here when we just have one selected. And then I expect that if we select the big bundle here from game dot, then maybe we can see that store. Yeah, here. I here it is. It takes like a little bit until all these functions show. Maybe, hard to say how long, maybe 300, 400 milliseconds. There's some delay here. It's not much, but I think it's because of this assert. So let's say we remove this assert. Compare. Yeah, and now we select it again, and now it's fast. Yeah, Okay, so I certainly this cell has a detriment on performance. We should fix that, yeah. Even if it's just debug. Okay, so essentially what we just do, we just build a hash map as we go on here. So we just reserve this hash map, and then we do here emplace index assert release assert assert dot contains dot count index equals 0, right? Yeah. Okay, there's a little bit more code here, so that's not good, but if the performance is better, then I think it's just fine. Compare. Okay, so we select this, and that seems to be fast. Yeah. Okay, we should certainly do that. Yeah. Now this actually has me wondering if has value is still used then at all. It's not. Maybe you can remove it again. Push back unique, is that used? It's not. So it looks like we don't really use these guys. Yeah, maybe we should remove them again. But I mean, they are useful if we talk about small sets, small containers, then it's fine. But yeah, with these containers that can have thousands of elements, then this is pretty costly. Maybe we add a note here. Use this for small containers only. For expected small containers only. Use hash maps for small containers, or rare uses only. Use hash maps for more intense, for longer lookups. For longer, and use this for small containers or rare uses only. Use hash maps for longer and reoccurring lookups. Okay, then we put this back in. Okay, then I think we have these things optimized. Okay, so blah 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 assets. Ta 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 ta. Yeah, let's test this one more time with the bundles that we have. So take this, compare. Okay, and now here we select all, everything good. Source files, select all good. Perfect. Yeah. Okay, this looks pretty good. Yeah. Now we can. Can also take this. Okay, so optimize n squared optimize n well, is that really n squared? Isn't that like logarithmic? Hold on. Time complexity charts. So n squared is I think it's not n squared, it's n log n. It's not O n. Well, it must be this then here. N log n. It can't be this. Certainly not constant. So it must be then somewhere here in between n and n squared. Yeah. N log n. Log n. N log n. I don't know if it's n log n. To me, it looks like the time complexity is n squared, half of n squared, because essentially, actually, hold on. Yeah, because with the first elements, it's with the last elements, it's n squared complexity, right? You reach the end, and then you have to, like, for every element go through almost the whole container, to all elements, to check, I don't know, one sec for 10 elements, 2 sec for 10, 3 for 40. One sec for 10, 2 sec for 20, 3 for 40. I don't know if it's logarithmic. To me, it's like half of n squared, but I'm not entirely sure. Yeah, who knows? Okay, it doesn't matter much. Optimize high complexity, high complexity linear searches in various GUI functions. Optimize expensive linear searches in various GUI functions. Let's say in GUI app. Expensive linear searches in GUI app. Yeah. Okay, this makes sense. Okay, great. So we got that. Next change, we want to runner async, right? So we want to remove all async commands for the bundled functions. Bundled. Okay, let's see. Which should be easy to do. Deleting is always easy. Okay. And in runner, bundled functions. There we go. Okay, and then maybe we can also delete this here, because this basically just, yeah, forwards the call, yeah, which is useless. Okay, so bundled functions are bundled there we go. Next. 1, 2, 3, and 4. Okay, great. Everything removed. Okay, let's see if that compiles. It does. Okay. Okay, just remove a bunch of code. All right. All right. 1, 2, 3, 4. All right. Good. Then we simply say remove async commands and runner functions for bundled move bundled versions of async commands and runner functions. Runner functions and async commands. Remove obsolete bundled versions of runner functions and async commands. Yeah. Does compile, that's great. Commits, done. Okay, so there's that. And so let's think. We need okay, so next thing we probably should look at is this file content storage, right? Let's go to that guy. Yeah. Okay, so the problem is with this thing, and right now there is no problem because our work queue is only on the single threads, right? So no practical problem right now. But if we would go to concurrent if we would go to a scenario where we have concurrent writes and reads to the storage from different threads, as we select our function, there will be multiple requests going to this thing. So there could be a scenario where this is not safe. The question is, how can we make it thread safe? I would like to avoid locking. And maybe what we can do is we don't pass our instance of the file content storage to process on, but instead we say, give us a new file content storage with these, like our current storage looks like this, and please give us a new storage with that. But this is a problem because then you can have, wait, no, that would maybe work. Oof. Well, whew. Well, maybe it does need locks, because if we let's say we say, okay, we have this file content storage, please build us more information about this for new file content that we need, and then you return us this, and then we merge it with our current file content storage, right? So we could do this, but then the problem is if we have multiple async commands kicking off, all with the same requirements, and they all want to load the same file, and then they all build this new file content storage. And then let's say there are 10 commands doing this at the same time. So all these 10 guys, they all load the same file, read it, and do the work. And then they all return, and they all say, hey, I have the new result you asked for. Yeah, but I didn't need it 10 times. I only needed it once, right? So that doesn't sound too good either. Oof. Well, find content, load content. I mean, we could add a lock in there. We could have a lock. And then, yeah. I mean, right now we have, there's a map, so all the elements here, they have stable references, right? Um, I think it's important that it's a map and not an unordered map, so that we never run risk of. Well, we could also have like a. No, I think SCD map is fine. Yeah. So as long as we don't call clear, it will work just fine. Yeah. Okay. So. Okay, so how about we before we jump onto this one, right now we have a pretty clean state here. Let's push the current stuff and let's get the let's fetch here from Baptista, since he made this Linux ImGUI edition. So let's stash what we currently have here. Then let's check out this one. And then I don't know why he put it into a B folder. Then let's merge this one into this branch. Keep a single branch line. What does that mean? Keep a single branch line merge. Huh? I don't have no idea. Let's just see what happens. It just worked. Oh, good. Okay, so let's see if that stuff compiles. My suspicion, well, my suspicion is it doesn't compile. Yeah, unless he tested it on Windows, but I suspect he did not. I think he did. He went blind. He just tested on Macintosh, probably. Let's see. If it doesn't compile, then we can't take it now. If it does compile and it runs, then I guess we can just merge it. Let's see. Aha. Yeah. There are errors. Maybe we can fix it for him if it's not too difficult. Let's see. Strings.h he put here. What is that? Okay, let's open the review. GitHub. Yeah, this one. So, asmmatcher.cpp. asmmatcher. Okay, so maybe he removed some folder here. Let's see. Here, WinCompads, privates. I think he removed this one. Yeah, we probably need to add it here. Let's do that. Yeah, I think it's important that he tests Windows. Yeah. Wait, hold on. Include directories. Did he remove this whole thing? Oh, you removed this whole thing. Wow. Well, that's not nice. That's not nice at all. Okay. So that is back. Let's see. Okay, so what do we have here? If defined Win32. What the hell? Okay, so this is not correct. It should be Win32. What does it include here? Win32. Win32. Here, for some reason, he uses a different Win32. Well, what should we use? Win32 or Win32? Looks like the other guys use Win_Win32. The demo uses it. FMT uses it. Yeah. Maybe we should use _Win32. Win32 1. Ah, I see. No, Win32 is also one. Okay. Okay. Well, let's go with _Win32 then, because all the other libraries we use here also use that. So maybe there's merit to this being superior in some way. Yeah. Okay, then let's put that here. Win32. I think there were some more here. Here, Win32. Yeah. Okay. Then let's see how far we get now. Oh, that succeeded. Great. Okay, well, I wasn't too much wrong. Then let's see if it also still launches and runs. Yeah, seems to work. Yeah. All right. Good, that still works. So, ta-ta, ta-ta. Good. Then we say fix Windows compile errors. All right. Then let's push this guy. Permission denied. Hmm. Um, permission denied. I guess he needs to somehow can you please allow me to push to this branch? There are Windows fixes necessary. There were Windows fixes necessary. If not Windows, what is this? CMake TXT. Yeah, let's open it here. If not Win32. Let's resolve. Function type CPP is gone. Okay. Resolve imgui app. And he removed all this stuff. Text filter imgui.h. Yeah. util.h. That was removed. Perhaps we can find a better platform name. not Windows. Okay, I think from my side things look good. We just need to he needs to allow me to push. I can't push somehow. Probably because I opened the pull request and not he. Yeah. That's probably the reason. I suspect I cannot push because I opened this pull request. You need to click a button somewhere that says that others can push to your branch. It's somewhere here, I think. Like a button where you can then say, yeah, allowed to push or something. I don't know, it's somewhere. I cannot see it because I don't own this branch, I think. Yeah. Otherwise, he would need to do the fixes. That's also possible. Yeah, you can watch my video to see the fixes. Yeah. Okay, good. Then, yeah. Let's take a break here. 1 hour 5, yeah. I think we can take a break, and then next session we need to switch back to our branch. Yeah. We do stash pop. Okay. Then we compile again. And yeah, we need to go to our, where's it? Here, file content storage. And we need to come up with some plans. So either we add some locks around these find content, load content, and size, yeah. And that should solve the problems. Otherwise, I mean, a lock, taking a lock is not expensive as long as a lock is not contended, right? So it could, yeah, it load content. Let me see what it's doing here. Yeah. Yeah. I mean, essentially, wherever we access the map, we need to put locks around. Yeah. Yeah. I mean, the other approach really would be the one where, yeah, we assemble a new storage and then we merge them. But yeah, there we can run into the scenario, also possibly unlikely scenario, but theoretically possible, that multiple file content storages are being built. and then they want to be merged, but yeah, all of these contain the same thing, so a lot of effort was wasted, possibly. So maybe the locking approach is just fine, simple enough. Yeah. Yeah. I think we try with the locks. See if that is manageable. Yeah. Should be simple enough. Okay. Good. Then yeah, we'll take the break. Wish you a great day or night. Until next time. Goodbye.